Good morning, Hire, and welcome back to school, strange as it seems. As you'll have seen from the Microsoft Team post I put last week, this week is all about consolidation. So for you, that's all about doing revision. When you physically return to school, you will be sitting your progress assessments. So for this week, I want you to continue with your revision towards that. And I'm going to show you today something that might help supplement your revision, which is using and accessing course reports, which are available from the SQA website. So you're going to open up a web browser and you're going to access the past paper and marking instructions from the past paper service as normal. And you're also, from the Higher Course Review page, going to access the course report, which is in this drop down here, which you may have seen before but maybe not given much thought of. So I'm going to use the 2017 course report, and equally I'm going to use the 2017 past paper and marking instruction. So in this course report, it basically gives you a review of how candidates performed in that year's exam. What questions they found pretty straightforward to attempt, and which ones candidates found demanding. And so it gives you a little insight into what you really need to do to make sure that you're successful with these type of questions. So if I move to section 2, it tells me comments on candidate performance. So that's the questions that they did quite well in, and these are the ones that they found demanding. So in particular, we're going to focus on question 2, which is related to collisions, explosions and impulse, and question 15, which is a skills-based question, or dare I say it, graphs. In addition to that, question 13 and 14 are related to the electricity unit, so you could use the reference here in order to help support you do those questions. But this is really about identifying which questions candidates find demanding to make sure that you don't make the same mistakes as them. Okay. So in particular, question 2A part 2 and 2B part 2 are the ones to focus on. So if I go to question 2 in the past paper, you can see that this looks like, on the face of it, a collision type problem. So it's related to momentum. So for the first part, we're asked to determine the velocity. So we're having to do a calculation of momentum before and after a collision. For the second part, we're asked to make a statement about what is meant by an inelastic collision. So this is the part of the problem where candidates seem to find demanding, they seem to struggle. Now it is only 1 mark, but in looking at the course report, it talks about how candidates in preparation for subsequent exams really need to make sure that they're familiar with their basic physics definitions. So that's what this question is all about. If I then fast forward to question 15, so the one I've mentioned, this is a skills-based question. So this contains aspects of physics which is not necessarily part of the higher course. So this is looking at the length of the wire and the resistance, including a new property called resistivity. Okay. And the part of the question that candidates struggled with here, it's not part A because that's just subbing the numbers in and you'll be pretty straightforward and good at that. It's this part B. It's doing the graph and calculating the gradient. Okay, so there's a lot of marks here. So it's important that we can actually do these different things. Okay. So let's look at the first one, question 2, and see how we attempt it. So what I would suggest is that you go to the question without looking at all the comment in the course report and try and do the problem. Okay? Which is what I've done. So if I click on my solution, and hopefully you'll be able to see this, especially if I increase the size of it, then there's 2A. So I've done the calculation to work out the velocity of the ball. The part in red is the part that candidates find demanding, so I've highlighted this for you to look at. So an inelastic collision is one where total momentum is conserved but kinetic energy is lost. I've then completed part B1, which again candidates found straightforward, and part B2, which they didn't. So for each part I've had to work out the percentage uncertainty in each component and identify what is the percentage uncertainty in the force, which in this case is the largest, so it's 2.5%. If I go back to the course report and look at what actually was it that candidates found demanding. So in 2A2, many candidates failed to provide correct definition of an inelastic collision. Many candidates failed to indicate that kinetic energy had decreased. So my answer, I've put a collision where total momentum is conserved but kinetic energy is lost. Does that answer it? Well, what I do is I go to the marking instruction and I look at part 2. Kinetic energy is lost or greater before the collision than after. Now, key thing here with the marking instructions, anything underlined has to be included in your answer. Okay, anything in brackets doesn't have to be there. So that's the expected answer, but you can see here what's not accepted. So EK before does not equal to using the do not equal symbol, EK after, or to say that EK is not conserved. Neither of those are acceptable answers. So although my answer is not the exact same word for word, I feel that I have answered it by saying kinetic energy is lost. If I then move on to the next part, which was looking at the percentage uncertainty in the force, I've calculated 2.5%. If I then go to the course report, it tells me that many candidates could not carry out the correct treatment of uncertainties. Candidates appear to be unaware that they should use the largest percentage uncertainty in the measurements to determine the overall uncertainty. And in some cases, if we read further in the course report, candidates didn't know how to actually do a percentage uncertainty calculation. Again, uncertainties is something that permeates through the entire course and you have to be able to do it. So if I again go to my solution, I've worked out the percentage uncertainty for time, for velocity and for mass, and I've identified that the percentage uncertainty in time is the largest, therefore the percentage uncertainty in force is 2.5%. If I go to the marking scheme for the question, then they've worked out 3 different percentage uncertainties and they've identified that the percentage uncertainty in the force is 2.5%. So in this one, we're getting 1 mark for working out 3 different percentage uncertainties and 1 mark for a statement of what the uncertainty is in the force. If we look at the additional guidance, so 1 mark for correct or implied working and 1 mark for the value. Must have percent in the final answer as that's equivalent to a unit. So if you've just written 2.5, you wouldn't get that final mark. Also, we've got a tolerance in terms of significant figures. So 2.5 rounded to 3 would also be acceptable. So this is an area that previously other candidates found challenging. If I go back to question 15 in my course report, this is a skills-based question. Question 15b in particular, it tells me many candidates fail to take into account the times 10 to the negative 3 in the table, despite having included this in their graphs. So if I go to my graph, and I've put both parts of drawing the graph and the gradient on here. So you'll see that on my x-axis I've got length in meters, and I'm using pretty much all of the graph paper because I've spaced it out. And on the y-axis I've got resistance, and I've put times 10 to the negative 3 ohms. Again, I'm using pretty much all of the axis. So it's a nice large graph, no prizes for the smallest graph possible. Now when I plot my data points, not all those points rest on my line of best fit. So I can't use those points. I have to use 2 points that are on the line to work out the gradient. And on this one I've written down what my gradient is. So I've got 3.8 times 10 to the negative 3 ohms per metre. Okay, so let's look back at the marking instructions for this one. So if we move on to question 15. There we go. So for B part 1, for the graph itself, suitable scales with labels on axes, which I'd put length in metres and resistance times 10 to the negative 3 ohms. Correct plotting of points, well, the marker would check that, but I'm going to assume that since I've plotted them, they're correct. And my line of best fit looks pretty much okay. So I get 3 marks for my graph. If I then go to the next part, to work out the gradient, I have to choose 2 points on my line, which I did. I didn't pick 2 of my data points, I picked 2 points that were on line. Now, if 2 of those data points were on the line, fine. If they're not, it has to be 2 data points from a line. Now, by calculating the gradient, accepted values are between 3.7 times 10 to the negative 3 and 4.0. My value was 3.8, so that's in between, therefore it's acceptable. Now, there's lots more additional guidance here in terms of where you can gain some marks, but also how you lose marks. But if I go back to the course report, let's see what they were saying here. Many candidates failed to take into account the times 10 to the negative 3, therefore they were getting incorrect gradients. Now, if I look further in the course report, we also get section 3, advice for the preparation of future candidates. That is you. So here's the first bit of advice. Centres should ensure that candidates can calculate the overall percentage uncertainty. Okay, so know how to do your uncertainty calculations. Centres should ensure that candidates know and understand basic physics definitions, so know what's meant by an inelastic collision compared to an elastic collision. If we continue further down, candidates should be made aware that the gradient of a line should be calculated using values from the line and not data points provided, which may not be on the line of best fit. So again, as I said, I picked 2 points on my line as opposed to 2 of my data points. So again, this course report is full of a lot of information that can be really beneficial and can really help you in terms of refining that revision. So I hope that this video introducing course reports has helped, and what I would suggest is that you try and work through this 2017 paper along with the 2018 and 19, identifying what are the questions that you can do and access, and use the course reports to help you look at the ones that candidates previously found demanding so that you can identify what the pitfalls are and hopefully make some progress and success with them. And I'll speak to you soon.